Okay, yeah, I might go ahead and get started. So welcome to today's signature lecture for the ARC Center of Excellence for Eco-Efficient Beneficiation of Minerals. I'd like to start by acknowledging the traditional custodians of country throughout Australia and their connection to land, sea, and community. We pay our respects to their elders, past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders people today. So today, our signature lecturer is Andrew Jenkin. Andrew is the Research Director of Mineral Processing at the CSIRO, which is one of our partner organizations, of course, with Colin and Nathan most active in our center. And so Andrew will be talking to us about the capabilities and current activities in CSIRO Mineral Processing. So thanks, Andrew.
Thanks, George, and welcome everyone. Firstly, thanks for the opportunity to present to you all today. I was really pleased to be asked, and I hope that you all get something out of this presentation. I'll preface it by saying I've left my technical expertise a long way away, a long time ago. It was in aluminium smelting. So I'm going to give you an overview of capabilities and activities. On a few of the slides, I've got some names or email addresses for you to reach out to if you have interest in those areas. But if not, just come to me. I'll put my email address on the last slide. So we're aiming for about a 30-minute for me. We'll see how we go with that, and really interested in the Q&A session that follows. I'll just sort of tag on to George's acknowledgement of country as well. I'm actually in Bunurong country. I'm in the red dot is where we are at CSIRO in Clayton, right next to Monash University. So we're in the beige area there, which is Bunurong country. The grey being Wurundjeri to the north. And just an interesting point. For those who know the geography around here, we have Port Phillip Bay, but in years gone past, Port Phillip Bay wasn't a bay, and the Bunurong people have been, hunting and gathering in that area for tens of thousands of years, up until 7,000 years ago when the water came in. So there's some Bunurong knowledge for you. I'm going to give you an overview, just a high-level overview of CSIRO for those who don't know much about it. I'm going to give you an overview of the Minerals Research Unit. I've got one slide on our characterization capability, and then I'm going to get into the processing area, which I lead. And you can see the breakdowns there of what I'm going to cover. I'm also going to make a bit of a plug for something that I do off to the side of my role, which is I'm a trustee of what's called the Education Endowment Fund of the MAusIMM. So I've got a slide on that, and then we'll have the Q&A. So just in terms of CSIRO itself, one of the world's largest science organisations, Australia's National Science Agency. I think it's around 5,500 people at the moment, right across Australia on many sites. We operate a lot of infrastructure on behalf of the government as well. There's small infrastructure in that photo, but over to the left-hand side, we operate radio telescopes. We have a large ship which assists with Antarctic exploration and R&D as well. And it's a bit dated, the $10 billion number, but I guess the point to make there is that we're really about impact in all its measurable forms. That's the primary driver for our existence. Our values tell you a bit about ourselves. The first one, again, flows on from that last statement I made. It's all about impact and making it real. So the science that we do, what's the ultimate impact on society, and particularly on all Australians. We've been around for 100 years. So we, I think, the alumni of CSIRO have built up quite a bank of trust and reputation, both in Australia and internationally, and that's coveted by listing it as a value. not surprisingly, it's really all about the people that deliver the great science. And lastly, the further together value, which is around collaboration. You know, just increasingly, it's becoming obvious that we can't do everything ourselves, even though we are large, and we have to work with others, both at the front end of science and also particularly when we're looking to deliver that science into the real world. The purpose statement is about solving the greatest challenges, and we have a new CEO, Doug Hilton, who's been with us now for about, I think, 18 months. So just wanted to give a bit of a flavour of some of the changes that Doug is instituting. On the left-hand side there, not out to the public yet, but it will be, so the CSIRO book, as it's currently called, sort of encapsulates all of the research going on inside of CSIRO at this point in time. It's never been done before. It's been worked on for the last year. So when it does get released, which I'm told is going to be pretty soon, you'll get a real overview of all of the areas that CSIRO is working on, and the filters or structures that we're putting in place to frame that is the high-level research areas that you can see listed in the middle, and energy and minerals of the most significance to us. And then on the right-hand side, the terminology we're using is programs of research. There's about 40 at the moment. And within energy and minerals, there's 7 I've listed, and the 4 in blue are really the ones that in processing we're most focused on. You know, it's really about the competitiveness of the Australian minerals industry. It's about critical minerals, and it's about decarbonisation and the green metals opportunity. So just in terms of, so 5,500 people within CSIRO, and within minerals, there's around 350. You can see the locations in Australia there, with Perth, Brisbane and Melbourne being the largest sites. Our overall budget is around $100 million per annum. Been around for a long time, active across the whole value chain. And I'll call it out again, you know, really got big drivers at the moment in the areas of decarbonisation and critical minerals. I just thought I'd go into our characterisation area here. It's not my area, but it's an important part of our work, and a great support to all of the work that we do in processing and other parts of the minerals research unit. So as you can see there, a wide range of instruments managed by specific scientific experts looking at mineralogy, textures, chemical, physical properties, across a range of scales, nanometers to kilometers, and 1D to 4D, grouped there into the 6 coloured areas, and they identify as having world-leading expertise in X-ray diffraction, electron probe microanalysis, and 3D characterization and diffraction contrast tomography in particular. And really, it's this, you know, it's the key scientists that we have that operate these instruments that is the competitive edge, where they're developing characterization workflows specifically tailored to problems and custom design quantification. So it's not just the assets themselves, the instruments. It's really the bank of scientific expertise that's been built up in this group for a long period of time. Now moving on to the processing capabilities here. Just a high-level slide to start with. It gives you a bit of a snapshot of the areas where we do have capabilities, and I've used the red and the orange to sort of call out where we believe we have some distinctive capabilities or significant capabilities. So I guess it's the breadth first and foremost. You know, our self-assessment can be debated, but you'll see where at least we believe we've got capabilities that are substantive. Now, firstly, I'm going to go into pre-concentration and beneficiation. I know that's a topic of high interest to the Centre of Excellence. So I've got a couple of slides here. The first one on pre-concentration, You know, the philosophy that's driving us here is listed in those first three bullet points. It's really about, you know, can we utilize selective breakage to pre-concentrate? Can we avoid, you know, breaking barren gangue components and reject them at coarse sizes, and really trying to minimize the mass of material that's ground down to a final liberation size. And one of the key technologies we're working on in this area is called the multi-stage selective liberator, or MSL, novel rock crushing device that's really trying to zoom in on this selective breakage sort of vision. Got some data on the right hand side there, you know, showing how it stacks up to a jaw crusher, where it's really trying to increase the value of accepted material for the crushing process. So we're piloting that at the moment in Brisbane, and getting some encouraging results with different minerals. It is, you know, very ore dependent. That's clear, and again, it comes back to that characterization capability and understanding, you know, what the target opportunities could be. Just in terms of beneficiation, I want to highlight work that we're doing in terms of semi-inverted cyclones. Again, up in Brisbane at our QCAT facility in Pullenvale. We're really trying to chase the value around misclassification of fines by conventional cyclones. The graphic in the top right's giving some data that we're getting in terms of the reduction in misclassified fines. You can see the facility there in the bottom right-hand side that we're using to test the semi-inverted cyclone. We're doing work there at pilot scale. We're also, you know, working with actual operations in South America, where some work is about to be done over there with our partner Net Zero Mining, led by Paul Ravel, who would be known to many people on this call. Really enjoying working with them. And we see the facility that we've built now as being of significant value to do a lot of the test work with actual ores at a reasonable scale, to prove up the value proposition for companies as well. So we think we're well placed in this space, and this is just one area of beneficiation. I mean, we have quite a long history of working in dry beneficiation as well, but at the moment we've reduced that work to focus in on these really large opportunities around the MSL and the semi-inverted cyclone. In the area of suspensions and CFD modelling, so I've got a couple of projects here that I wanted to talk about. But first, the lead in from a capability perspective, we have a CFD team of 5 people at the moment who are really experts in the area of multi-phase flow systems, led by Peter Witt. And we have a suspensions team of around 12 or 13 people who have a long history of working in mixing, scaling, erosion, separation of solids and liquids, with significant focus on the alumina industry, but also working into gold and other areas as well. One of their core technologies is on the left. This is the swirl flow mixing technology. You can see the graphic where the impeller is actually quite high in the tank, and it creates a vortex or a tornado to ensure good mixing. This has been operating in several alumina refineries, but particularly the Queensland Alumina Refinery in Gladstone for many years now in a lot of their tanks. And we're rolling it out in other locations. There's some in the Yarwun Refinery in China now, in India now as well. And the models in the bottom left, both CFD and physical models, are what underpins our knowledge of how this system works. So we use both CFD and physical models for different reasons to extend the technology into different applications and different tank shapes and configurations. On the right-hand side is dry slag granulation technology. Talk about the technology first and then the modeling. So currently, slags are typically just cooled with water, which uses a lot of water, wastes a lot of energy. So this technology was developed several years ago here in Clayton, where I'm based at CSIRO. And the idea is that you don't use water and you cool in air with a spinning disc. So the video in the top right is showing this spinning motion and the slag getting distributed to the edges of the device, breaking down and granulating in air. And then that gives you the opportunity to run countercurrently and capture the hot air and then generate electricity, from that. So you're capturing value from it, and you're not using water as well. So this technology was piloted here in Clayton, and is now being demonstrated at full scale in China at an active steel plant alongside a blast furnace. They've had several runs. They're still commissioning. There are some teething problems in some of the ancillaries, which is quite often the case when you're doing this commercialization or demonstration activity. But they have been running for several hours, and they have been producing granulated slag, and you can see the image down the bottom there as to what they're producing. So we're hoping that work continues and that is successful, and that we get to see this technology rolled out globally. But yeah, it was the CFD modeling in particular that was very helpful in terms of designing this process and in terms of scaling it up in terms of the Chinese operation as well. So a lot of multi-phase flow work for our CFD team to optimize in this technology. Into the hydrometallurgy area, which for us is based in Perth at our Waterford facility. You can see there I've listed 4 capabilities that we specific capabilities that we have there. I'll really call out the process development capability in terms of scaling up, doing a proof of concept and into piloting. The image in the top right is our PCAM facility that we're working with Curtin University. Originally, it was part of the FBI CRC who funded that capability, and we worked on it with Curtin, and now we're continuing on that with funding from Mariwa. But that's very important in terms of the crystallization piloting opportunities. We've been focused on PCAM, part of the battery story, and but it's really just one example of the type of scale that we work at Waterford once we've come out of the laboratory. Bottom left gives you a bit of an overview of some of the commodities that we're working with, and it's very critical minerals focused at the moment. Historically, the Waterford capability would have been pretty heavy in gold and alumina as well. Gold's sort of held firm, maybe come off a little bit. Alumina, since the Parker Centre CRC ceased, has fallen quite significantly, and I guess that's what's made way for us to move into critical minerals, particularly titanium, vanadium, nickel, cobalt, manganese, and very lately, with some funding from the Australian Critical Minerals Hub, we've been getting into the area of high purity alumina, and can we design a new process for producing that in Australia. On the right, we've also developed a novel graphite purification process that doesn't use hydrofluoric acid like the current process does. So we're currently working with a commercial partner on that to scale up that technology as well. Just an overview slide of our, when I say our, this is all of CSIRO's work in battery, the battery value chain. And I didn't intend to go into the detail here, but clearly our mineral processing experts are working in the top right there in terms of work around electrolytes and precursors, and perhaps some metal as well. But I think it shows what CSIRO can do when it really leans into a space, because we've got other parts of the organisation that are working in terms of battery, different battery technologies, battery chemistries, battery performance, battery safety as well, and then also the recycling, piece too, and mining. So because of our size, we're able to traverse, the value chains. That means when we're talking to either international partners or governments, we've got an interesting perspective because we have the breadth in certain areas. In the pyromet area, we are pretty focused on steel or iron, and also aluminum, aluminium with the government. I'll talk a little bit later about a new initiative that they've asked us to lead. We also are involved in magnesium and lithium metal production, but yeah, very dominated at the moment by the iron opportunity. And the point that's made on this slide here is that what we're trying to do is we're trying to build pilot scale capabilities, tens of kilos across the whole green iron value chain, or what that value chain might look like. So we've got existing capabilities up in Brisbane around oxide pellet production capability and testing up at QCAT, and we're trying to augment that down here in Clayton with electric smelting furnace capability, which we've purchased but not yet commissioned. We're also seeking to add fluidized bed gas reduction capabilities and DRI as well. So our aim is to build end-to-end green iron testing capability here in Australia, with the large vision of the green iron opportunity for Australia very much in mind of government, and also some of the major iron ore producers. So this is an exciting area for us that's changing pretty quickly, and we're really pleased to be involved in this area with our pyromet capability, which we've had for many years, but has been largely focused up until relatively recently on base metals production, and whilst we still do occasionally some work in that space, we're very much on the iron story now. We have an electrochemistry capability again here in Clayton. It's active in several areas, doing some work on hydrogen electrolysis or production of hydrogen from electrolysis. But the one thing I thought I'd show and focus on here is some electrochemical sensor technology that we've been working on for several years, particularly targeted for mining use. Either the top right images, one is in terms of in situ recovery operations. We've been working in South Australia testing our first generation pack system down boreholes to measure water quality in different locations around in situ recovery operations. That's in South Australia. And then on the image on the right, in Tasmania, we've been testing the system down there as well in areas that could be susceptible to acid mine drainage. We've upgraded the pack. You can see the second image now. It starts to look more like a lightsaber, I think, and so do my kids. A bit more robust and able to be put down smaller boreholes as well. So we're looking at multiple applications for this technology, and even including on the bottom right there, we're looking to move from aqueous analysis to gas-based analysis. And the first application we're looking at is coming from a biosecurity perspective. We believe we've designed a system which can detect and identify specific insects via their pheromones. So this could be, this is something that's of interest to our health and biosecurity area within CSIRO, and interest to scanning. The idea is to scan containers that are coming into Australia and not have to open them up to determine if there might be a biohazard involved. From a mining perspective, we're thinking after we do this, we've learnt now in terms of gas analysis and be able to take it into mining, whether we detect hydrogen or methane or hydrogen sulfide. So they're the next sort of thoughts that we have as to where we could take the technology next. Just some general, small number of general slides. In terms of our partners, I've divided them up there. This is probably a list of current partners. So clearly we've worked over a long period of time. We have relationships which sort of come and go, but we do work with small companies, large companies. We're very active with university partnerships, whether it's direct to a uni, a collaborative research centre, or an ARC such as yourselves. And increasingly we're working directly with government departments as well. This is something that in minerals at least didn't happen a lot. We were much more focused on industry, but government is getting more active in the areas of decarbonisation and critical minerals, and so we are getting some direct funding and also leaning in to try and help them in their policy setting areas as well. And with the industry associations I've listed there, to varying degrees, we're working with all of these four organisations. And I was mentioning to George beforehand, the MAusIMM, we have a strong relationship with them. We sponsor conferences, we co-lead the iron ore conference as well. So, very supportive of their activities. Just in terms of those government linkages that I mentioned, I just thought I'd give an overview of 4 major initiatives that are directly funded by the Australian federal government. Critical Minerals R&D Hub is a collaboration between ourselves, ANSTO and Geoscience Australia. $50 million over 4 years. We're now sort of 3 years into that initiative. And we're all wondering kind of what happens next with that, but we're really pleased to be able to work with our co-agencies, and there's some pretty impressive science that's been accelerated because of that funding. Then there's 2, so the top one's funded by DISA, the Industry, Science and Resources Department. Then the 2 in the middle are funded by DFAT, Foreign Affairs, so some specific funding to work with partners in India on shared opportunities, one in critical minerals, one in green steel. Again, 3.5 sort of 4-year deals with 1 year to run. Yeah, we've been really pleased with what we've been able to achieve there. It's not easy sometimes partnering with India, particularly from a contractual perspective, but we've found some really like-minded research organisations and commercial entities that are facing significant challenges or opportunities very similar to Australian companies in the green iron area. But in the critical minerals area, it's more about how can we link our supply chains together. What might we be able to do here from a supply, add a bit of value, and then get it over to India for more downstream or final processing, whether it's in the battery value chain or something in rare earths as well. And the final one is hot off the press. I think Minister Ayres announced this about 2 months ago, the Green Metals Innovation Network, or GMIN. So it's CSIRO-led out of the processing program, but in a very strong partnership with the HILTS CRC out of Adelaide. So early days here, but $10 million over 4 years to really try and bring together the green iron and aluminium. So it's very focused on those 2 elements, the ecosystems that are trying to decarbonise those industries and look for future opportunities for Australia to grow in that space. And it's a bit about infrastructure provision. It's a bit about some research projects, but it's also about trying to grow talent in this area and to share knowledge across the ecosystem. So Keith Fining, who reports to me, is leading that, and we're really in the forming stage at the moment where we're constituting industry panels, one around the iron value chain, one around the aluminium value chain, and getting input as to where the biggest levers are to move the dial over the next 4 years with this construct. And yeah, finally, the AusIMM Education Endowment Fund, because there's going to be students on this call, I thought I'd take the opportunity to to talk about this. So I'm a trustee or a member of the board of trustees that oversees this fund of money, which was set up in the late 80s, but really grew strongly in the late 90s, and is designed to support people, professionals who are coming through the university system and are very interested in joining the minerals industry. So it's a scholarship that we pay to support undergraduates and also postgraduates, more in the undergraduate, but definitely some in postgraduate as well. It always was the scholarship, but what we've been finding lately is we've been putting on more additional benefits, and these are really starting to attract people and really be appreciated. So one is a mentoring program that we've been doing for the last 2 or 3 years, fully funded, and the other one is the annual field trip, which this year, and it was only 3 or 4 weeks ago, I went down to meet the students myself, was in Tasmania. So that's a whole week, totally customized itinerary around Tasmania, which takes in the whole mining value chain. And so there was 15 undergraduate scholars and 1 PhD scholar that went on that tour, and you know, got amazing positive feedback. So applications are opening for scholarships in 2026, and I think it's going to open in the next month or so. But if any of the students are interested in this, I'd highly encourage you to take a look and apply online on the MAusIMM website. Okay, George.
Thank you. Excellent. Thanks for an overview of what you guys at CSIRO are doing, and it's interesting for me to hear about some new technologies and things that I hadn't heard of before.